For this example, we are asked to find the global maximum and global minimum of f of x is equal to x to the third minus x squared minus 21x plus 15 on the interval from -3 to 4. We know we need to compare the values of f at critical points and endpoints. The endpoints are given in the problem. We must find our critical points. So we take our derivative, f prime of x. In this case, we get 3x squared minus 2x minus 21. And we want to know where 3x squared minus 2x minus 21 is equal to 0. This is a quadratic whose leading coefficient is not 1. If we want to factor, we can use the AC method. Do 3 times -21, we get -63. We need two numbers that multiply to give -63 and add to give -2. They would be -9 and +7. So we're going to separate that middle term and rewrite as 3x squared minus 9x plus 7x minus 21 is equal to 0. Once we have created four terms, we can factor by grouping. Out of our first two terms, notice that we can take out a 3x, and it would leave behind x minus 3. Out of our next two terms, we will take out a +7, and it will also leave behind x minus 3. We now have a common factor of x minus 3 that we can remove, and it will leave 3x plus 7 is equal to 0. We now use the 0 property that tells us that if two values multiply to give me 0, one or the other of them has to be 0. So either x minus 3 is equal to 0, in which case x is equal to 3, or 3x plus 7 is equal to 0, in which case 3x is equal to -7, and x is equal to -7 over 3. The values x is equal to 3 and x is equal to -7/3 are our critical points. So we want to compare the values of f at critical points and endpoints. So we look at f of -3, f of -7/3, f of +3, f of +4. We can use the table function on our calculators to calculate these values as +42, 45.852, -30, and -21. The highest value is our global maximum, and the lowest value is our global minimum. So our global max is 45.852, and our global minimum is -30.